13.4 is going to cover a review topic for us from geometry called the law of sines. Now remember when we have SOHCAHTOA and we have a squared plus b squared equals c squared, and we have 1/2 base times height equaling area. All of these are dealing with right triangles. If you don't have a right triangle, or in the case of area, you don't know the altitude or the height of the triangle, those you're out of luck. So what happens in the math world is that we find ways to work formulas with all things. So law of sines works for non-right triangles. So first we're going to handle the area. Up until now, the only way we could find the area of a triangle is if you had the base and the height, you had a picture like this with the height and the base, or you had a triangle like this where you had your height and your base. And we always went ahead and looked for that right angle, and those two dimensions that made that right angle were what we used. Well, if we don't have that 90-degree angle, we haven't been able to do it until we get this sine business. And what I can do is I can find the area of any triangle as long as I have that side angle side situation. Remember from geometry, the two sides and the included angle. So here, if you look at this 1/2 BC sine A, here's A, here's B and C. And if I plug those numbers in, I can find the area of my triangle. So let's look at some examples. Here's my angle. So if I take 1/2 of 9 times 9 times the sine of 40, I have 1/2 of 81, and the sine of 40 is 0.6429. I would recommend always carrying 2 to 3 decimal places. And when you put that into your calculator, you get 26.03 centimeters squared. And that is the area of that triangle, and you did not know what the 90-degree height was. Same thing's going to be true for this one. I'm going to take 1/2 of 12 times 15. Those are those sides that include the angle times the sine of 58. Here, I'm going to go ahead and clean this up. 1/2 of 12 is 6. 6 times 15, I'm going to have 90 sine 58 to put into my calculator. The fewer things I have to put into my calculator, the more likely I am to get it right. And when I do that, I end up with 76.3 meters squared for my area. Remember, the label on area is always squared. Now, this is our review from geometry, the law of sines. This rule lets us set up a proportion between the sine of an angle and its side opposite, the sine of A and its side opposite, the sine of C and its side opposite, the sine of B and its side opposite. And if you know 3 out of 4 of those measurements, you can set up a proportion, cross multiply, and solve. And the place that we are using this, if you go back to geometry, is we are going to use the law of sines when we have the angle side angle situation where I know 2 angles in the included side. We're going to use it when we know angle angle side, 2 angles in the non-included side, and we are going to use it for the side angle case and we will get a flow chart to help us with that scenario. Now we're not proving triangles congruent like we did in geometry, but we're using that language from geometry to describe situations like knowing an angle, a side, and an angle. Knowing an angle, and one of the two non-included sides, and in this case, knowing an angle and two sides. So, let's look at this situation. I have angle, side, angle. Remember when we solve, it's find all missing parts. So in this case, I have 3 parts I need to find. Sine of B and its side opposite 9 are the place where I'm going to start because that is what I'm given. Sine of 53 over 9. I know 100. I don't know its side opposite, so I'm going to do the sine of 100 over C. That's going to be the first place that I start. And when I cross multiply, I end up with C sine 53 is equal to 9 sine 100. And notice that I put that 9 and that C in front of the sine, so then there's less chance to be an error. I'm going to divide both sides by the sine of 53. If you do all of this and don't go to your calculator until the very end, you're much less likely to introduce that rounding error. And so here, be careful with your calculator. I would actually do sine 100 equals times 9 equals divided by sine of 53, and C is going to come out to be 11.1. Now, finding A is going to be my second step. Now, I could have done this first. The order doesn't really matter. Angle A is 180 minus 100 minus 53, which makes it 27. And I needed to find that because now I need the sine of 27, its side opposite. I'm going to go back and use 53 and 9 because those were my given values. And I'm going to say the sine of 53 over 9 is equal to the sine of A over A, except now I know what A is, and so I can go ahead and say the sine of 27 from right there. Cross multiply, A sine 53 is equal to 9 sine 27. Divide both sides by the sine of 53. Now remember, the sine of 53 is a number. It is a trig ratio. Go to your calculator. Don't forget your parentheses. And A will end up being 5.12. Now keep in mind, you have some sense of your answers for those sides and those angles before you begin. 100 is your biggest angle, so C better be your biggest side. If you get to the bottom with C and that number is less than 9, you know you did something wrong. 27 is your smallest angle. That means A better be your smallest side. So the sense of the answers and the ability to kind of do a mental check is a great trick when it comes to some of these concepts. Now, we said in geometry that side-side angle, or a potty word as I usually called it, could never be used to prove triangles congruent. And the reason it can't be used to prove triangles congruent is because of this chart right here. 3 different things can happen. You can actually have 0, 1, or 2 triangles being formed. So, in your notes, you'll see you have a very nice flow chart at the end of this lesson. The flow chart is kind of a summary of this chart you're looking at. If A is acute, you are going to follow into these 2 situations. If A is right or obtuse, you're going to have one of these situations, and this is how things are going to break down for us. So let's look at some examples. First order of business, what is A? A happens to be obtuse. So what does our flow chart say? if A is obtuse, then I have to look at how do A and B compare. Well, in this case, A is greater than B, and on my flowchart, that tells me, therefore, I have one solution. Once you know that, you can go ahead and solve your triangle. Those are my two values I know to start. I'm going to go ahead and set up a ratio. Now, I know 17, that goes with B, and so that is where I have to start. So the sine of B over 17 is equal to the sine of 118 over 20. Cross multiply and divide. We're going to end up with the sine of B being equal to 17 sine 118 all divided by 20. And when you work that out, you end up with B equaling 48.6 degrees. And you can then go through and find step 2, angle C is equal to 180 minus 118 minus the angle I just found, 48.6, and so angle C is 13.4. Step 3, I'm going to go ahead, I'm going to go back to A, that was my given. The sine of 118 over 20 is equal to the sine of 13.4, which I just found. Opposite little c, cross multiply, divide. C ends up being 20 sine of 13.4 all over the sine of 118, which makes C 5.25. And again, when I take a quick peek, 13.4 is my smallest angle, C is my smallest side, 118 is my biggest angle, 20 is my biggest side, and everything works. Tune in to part 2 of the video for the rest of the options for side-side angle.